Hello everyone, this is Gowzahr, the self-proclaimed physics detective. Today I'm here with the first in a two-part series talking about a topic that I care deeply for. The differences between black holes and wormholes. Now these two phenomena are so radically different that it's infuriating that sci-fi writers confuse the two so often. So I'm here to set the record straight. Fortunately, The Force Awakens provides the perfect setting for discussing the two. Star Killer Base. So, without further ado, let's talk about wormholes. They don't say much in the movie about how the superweapon works, only that it's a hyper-light-speed weapon and that it's powered by consuming stars. Personally, what makes the most sense to me is that the superweapon works by sucking in stars and then firing them through wormholes. But what is a wormhole? To answer that question, we need to talk about Albert Einstein. In an effort to explain certain intriguing observations that his predecessors had made, Einstein proposed that matter and energy warp the fabric of space and time. The mathematical frameworks he developed to relate matter and energy densities to the curvature of space are what we know today as Einstein's theories of relativity. It's the bending and folding of space that makes wormholes possible. So with that in mind, let's say this piece of paper is the universe. If an ant wanted to travel from the top of the paper to the bottom, it would have to walk the entire length of the page. However, if the page were bent like this, and a pencil were inserted through the punched holes like this, then the ant would have a much faster, more direct path to take. That's what a wormhole is. It's a bridge that connects two spatially distant points across some curvature. Now there are two important things to talk about with respect to wormholes. First, notice that in the example of the paper, the wormhole was only made possible by allowing the two-dimensional paper to exist in a three-dimensional space. What that means for the real 3D universe is that wormholes can only properly be viewed as we watch the three-dimensional universe twist in four-dimensional hyperspace. This has two important consequences. First, it makes it very hard to draw, which is why we looked at a flat universe. Second, because wormholes require at least one more spatial dimension than make up the universe, traveling through a wormhole could be considered hyperspace travel. The second important thing to talk about is stability. Wormholes are theoretically possible in that they satisfy Einstein's field equations. One complication, though, is that in order for a wormhole to remain open long enough for matter and/or energy to make it from one side to the other, they have to be stabilized using exotic matter. Exotic matter is a term that is usually applied to one of three cases. First, types of matter, such as tachyons, that, as far as we know, don't exist, and that physicists believe cannot exist because they violate the known laws of physics. Second, particles that we believe can or do exist, such as dark matter, but which have so far eluded our searches. Finally, there are types of matter that are rarely seen, such as Bose-Einstein condensates, which do exist, but which exhibit properties very different from solids, liquids, gases, and plasmas. Unfortunately, the kind of exotic matter needed to make a wormhole transversible falls under the first category. But hey, so long as we're in a galaxy far, far away, where there exists a mystical force that surrounds us, and penetrates us, and binds the galaxy together, then why not have matter with negative energy densities? Well, that concludes part 1. I'd just like to close by saying thank you for watching. If you liked this video, then be sure to keep your eyes out for part 2. When it's ready, I'll be sure and post a link in the description below, as well as making this black hole a clickable link. You can also show your support by liking this video, subscribing to my channel, and maybe even following my Facebook and Twitter pages. Once again, this is Gowzahr, the self-proclaimed physics detective, signing off.